Hi everyone, welcome back to another Calculus 12 video. We're doing 9.2 today, differential equations with initial conditions. I feel like the titles make it sound like a bigger deal than it actually is. So we're going to run through this example and I'm going to try to convince you that it's not a big deal. It's the same old stuff we've been doing all along. It says, find the curve y equals f of x that passes through this point, negative 1, 0, and satisfies this equation, dy dx equals 6x squared plus 6x. Okay, so basically the derivative has been given to us. It's kind of like we're working backwards. So let's apply this and take a look at what this means or how it shows up. So, first of all, since dy dx is the same thing as f prime of x, well, I could rewrite this. I just find this easier to work with. Totally your choice. You can leave it as is, but I just find it a little bit easier to say f prime of x equals the 6x squared that we had plus 6x. So it's just basically rewriting it in the usual form that we're used to seeing. And so if this is the derivative that we have, we can sort of work backwards. Oh, that needs to be thicker. To say, well, if that's what the derivative is, can we work backwards to think of what the original function must have been? So in order to think backwards in terms of what the original function must have been, well, if we take a look at this term and we're working backwards to find the original, then we would get 2x cubed plus, I'm going to do this in different colors. Here we would have 3x squared. And then remember that at the end we always have, whoops, wrong color. We always have plus c. So let's sort of talk our way through this because I just wrote them down, but I didn't really review with you how we came up with this. So if we analyze this first term, if we're working backwards to find the antiderivative or go back to the original equation, we know that we would take this up here and we would plus 1 to it. So that accounts for how we got this x cubed. And then based on what we normally do when we're taking the derivative, we normally would pull this down and multiply it. So in order to get this 2 here, we would be thinking backwards, that if we were pulling this down to multiply this out, so we would add the 1 there, and then we would divide by, like that would give us the x cubed. We would take the 6 and divide it by the 3 that would have been up here, and that's what gave us the 2 in front. So that's how we came up with this first term here. When we look at the second one here, same idea. I would take this and say, okay, there's a 1 there. We just never write it. I would be adding a 1 to it. That would give me x to the power of 2. And in order to get what goes up here, I would take that 2 that would have been up there and I would divide this by it. And that's how I got the 3 down here. I feel like I'm not being super clear and articulate. Hopefully you've understood that because we've done it before. So that's how we're getting this 3x squared. So that accounts for this term. And then just a reminder, because this is something that people often forget, is we always need to put the plus c at the end because if there was a constant there, when we took the derivative of it, it would have been gone, which would have left us with an empty space or nothing there when we're looking at the derivative. So going back to the initial information that was given to us, it said, find the curve, blah, 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 that passes through this point. So if it's passing through this point, negative 1, 0, then I'm trying to figure this out. So I'm going to say now, f of negative 1 equals 0, since they're saying that this point must be on there. That's what it means by saying that it passes through this point and satisfies this equation. So I'm going to say this too, since negative 1, 0, that's the point that was given to us, is on y equals f of x. So we can take that and plug it in. So we get a 0 here equals, we're going to take our original, this f of x that we have here, and we're going to plug in that minus 1. So in here, I'm going to say 2. Actually, why don't I color code it? So I'm going to say 2, and in here, I'm going to plug in that minus 1, and it's going to be to the power of 3. So that's our first term there. To get to the next one, again, I'll color code it. So it's going to be plus 3. I'm going to plug in that minus 1 squared. And then at the end, it's the plus c that we were talking about or working with. So you can see that we're taking all the information that was given to us. I feel like that might be too small, but hopefully you're able to zoom in on your screen and look at that. But just so we can see all the information together, if it's passing through that point negative 1, 0 and satisfying that equation, then this is just us plugging in that point negative 1, 0 right here into the f of x that we've just found, and it allows us to figure out or isolate our constant if there is one. So that's basically what we're doing here. And for the sake of my sanity, I think I'm going to stop color coding at this point because I think we're good with that. But when we do work our way through this, actually, you can do the math on this. You all can do that in your head. And we would find when we do all that, isolate it, move it over, c is equal to negative 1. Okay, so c equals negative 1. What did it say? Find the curve that passes through and satisfies this equation. So basically, therefore, I feel like I need to do it in this color so that you can see it properly. Y, or maybe I should say f of x, whatever you feel more comfortable with, it means the same thing. We'd have 2x cubed plus 3x squared, and then we're just filling in that plus c, which we found to be minus 1. This is, I'm going to put that in a box because that's our answer. This is the curve. That's it. So hopefully you believe me when I say that the title makes it sound like a big deal, but it's so not a big deal. So you can do numbers 1 and 3 all on page 411, and that's it for this.